There's a very important concept in electrical engineering that any hobbyist can use, and that is resistive equivalence. The idea being that you can combine two resistors in such a way that there is a single resistance acting between the two terminals. And this comes in very handy whenever it comes time for you to, let's say, calculate the current on this branch, or if you want to calculate the voltage difference, the potential difference in voltage between these 2 points here. And the idea is that for these two resistors, suppose we have 10 ohms and 30 ohms. The equivalent resistance between these 2 points is, now this is very simple. This is 40 ohms. Can you guess how we did that? That's right. We just added these two resistances. One plus R2. Now, this one is a little bit trickier. And I mean that in a good Christian way. So let's suppose we have, let's just make it easy for ourselves. R3 is equal to 100 ohms, and R4 is equal to 100 ohms. Now, the general formula for resistive equivalence in when you have two resistors in parallel, that being the positive ends of both resistors are wired together in one node. This is a node. This is a node. And the negative ends, and I mean that, of course, with respect to the overall flow of the circuit, current within the circuit, because obviously there's no positive or negative end of a resistor. But within the circuit, obviously there is a positive end and a negative end if it has current going through it. Now, the formula for resistive equivalence, let me just sketch this out. REQ equals, we want to know the overall resistance because we want to know, say, the current going through this branch. So suppose we do the math now. The formula for figuring out this equivalent resistance is 1 over that resistive equivalence is equal to 1 over R3 plus 1 over R4. And we can generalize that by saying that the resistive equivalence is equal to a sum from I equals 1 to n of, actually let me make it very general, Ri to the negative 1 to the negative 1 power. So we want, in this example, just the resistive equivalence of 200 ohm resistors in parallel. So 1 over Req is equal to 1 over 100 plus 1 over 100. And that is equal, and that comes to 2 over 100. So that becomes 1. That becomes 50. And, oh look, we can just say now 1 over resistive equivalence is 1 over 50. Well, that would imply that the resistive equivalence is 50. Equals 50. So I have an example. Actually, I have just such an example right here. And this came about because I was in a very popular tool chain brand store. It rhymes with Lady O Schmack. And there was a fella in there who couldn't find the exact resistor that he needed. Needed actually a 50 ohm resistor, and they were fresh out. And this got me thinking about how, the resistive equivalence works and all that. So as you can see here, we have 200 ohm resistors, and we want a 50 ohm resistance between the positive and negative ends. So as you can see, I have wired up. I got them on my breadboard. I just had these extended down a bit so that these wires wouldn't be bunched up and in the way. But as you can see, both of these ends of the resistors are wired up to the same end. Let me just so you can get a better look at the other end. I apologize for the perspective a little. And right here you can see they have both of these resistors wired up on these two ends. And I have my handy ohm meter ready to go. So watch what happens. Again, I apologize for the perspective. I'm going to, let me see if I can. Zoom out here. We are looking for 50 ohms. Say now, that's pretty good. Well within tolerance. And that is how you can combine two resistors to get a third resistance value you might want. And it's particularly useful whenever you are dealing with limitations such as time or money, not being able to go out and buy every resistor they have available. And you can definitely work around anything you might need, any obstacle that might be in your way. And thank you and have a great day.